quantum computing. You know, for years, it's felt like something straight out of science fiction, but we are right at this critical turning point. This technology, it holds the key to solving some of humanity's biggest problems, but at the same time, it presents one of the biggest security threats we have ever faced. Okay, let's dive right into this quantum paradox.
So yeah, the era of this all just being theory, it's officially over. At the recent CES conference, some of the biggest players in the game, like IBM, they actually put a date on it. By 2026, they expect what they call quantum advantage. That's the moment a quantum computer can solve a problem that even our most powerful supercomputers today just can't. This isn't some distant dream anymore. It's basically a deadline.
And that's really the central question for us today, isn't it? This massive leap forward brings two very different futures with it. I mean, one is a future of unbelievable discovery and economic growth. The other, well, that's a future where the very foundations of our digital security just crumble. So the question is, are we ready for it?
First, let's talk about the incredible upside. I mean, this is the reason that nations and giant corporations are pouring billions and billions of dollars into this tech. This is the trillion-dollar promise.
And the scale we're talking about here is just immense. According to research from McKinsey, quantum computing could generate up to $1.3 trillion in value by 2035. And yep, that's trillion with a T. But where in the world does a number that huge even come from?
Well, all that value comes from quantum's unique ability to solve problems that are just computationally impossible for our current supercomputers. We're talking about designing new life-saving drugs molecule by molecule, or optimizing the entire global financial market in real time, or untangling these impossibly complex logistics networks, and even supercharging the next generation of artificial intelligence. These are game changers. You know, an analogy from that CES panel really brings this home. Just think about it. Remember how AI felt kind of like a curiosity just a couple of years ago, before it suddenly exploded and became this transformative force? Well, the experts are saying quantum computing is right at that same exact point. The exponential growth is coming, and it is coming fast.
But, and this is a huge but, with that immense power comes an equally immense threat. We have to pivot now to the dark side of what quantum can do. Because while one team is building something incredible, another is preparing to break everything, and the clock is ticking.
This brings us to a really chilling strategy known as harvest now, decrypt later. What this means is that adversaries, right now, today, are actively stealing and stockpiling encrypted data. We're talking government secrets, corporate intelligence, your personal information, all of it. And they're just sitting on it, with the full intention of unlocking it all the very moment they get their hands on a powerful quantum computer.
Just take a look at this chart. It really shows you the timeline we're up against. It's tracking the experts' estimates for when a quantum computer could break something called RSA 2480. Now, that's not just random letters and numbers. It's the encryption standard that protects pretty much our entire digital world, from bank accounts to national security data. As you can see, the likelihood just climbs dramatically within the next 10 to 15 years. This isn't some distant problem. The data being harvested today is already vulnerable.
So with this two-sided coin of promise and peril, a global race for readiness has totally ignited. Nations and businesses are scrambling to prepare, but as you're about to see, being aware of a problem is a very different thing from actually being ready for it.
And this readiness gap is crystal clear when you look at data from a recent executive survey. Get this, 80% of CEOs see quantum computing impacting their business. That's huge awareness. But only 40%, less than half, feel their organization is actually prepared for it. That is a massive gap, and it's right there where competitive advantages are going to be won and lost.
And on a national level, this readiness gap is just fueling a massive global competition. This map here shows public and private investment in quantum as a percentage of GDP. And as you can see, from North America to Europe to Asia, all the major economies are pouring resources into R&D, all of them vying for a strategic advantage in this coming quantum era.
And this push for awareness, it's happening at the highest levels. I mean, the United Nations has even declared 2025 the International Year of Quantum Science and Technology. The whole goal is to raise public understanding of what's at stake and to try and work towards a future where this powerful technology is developed equitably and, safely.
So how do we actually build this future? How do we harness the promise while defending against the peril? Well, the answer lies in these incredible technologies that are being developed right now on the absolute frontier of science. Okay, so a huge challenge in quantum computing is that qubits, the basic units of quantum information, are incredibly fragile and prone to errors. The solution is something called quantum error correction, which basically uses a bunch of these fragile physical qubits to create a single super-stable logical qubit. And this roadmap from the company QuEra shows just how fast things are moving, from just 10 logical qubits this year to 100 by 2026. And that's the point where these machines are really going to start to outpace classical computers.
Now, on the security side of things, the ultimate defense is a quantum internet, a network that's secured by the laws of physics itself. But sending these delicate quantum signals over long distances is really tough. So the key piece of tech we need is a quantum repeater, which is a device designed to extend these quantum connections across the globe without them just fizzling out.
This visual gives you the basic idea. Instead of trying to send a fragile quantum signal all at once, a repeater creates this special quantum connection called entanglement over a short distance. Then it passes that connection along to the next repeater, kind of like a baton in a relay race. By stitching these shorter, unbreakable links together, you can form a secure connection over thousands of kilometers.
And while ground-based repeaters are one solution, the next great leap is to go to space. See, fiber optic cables cause the signal to degrade, but satellites can transmit these quantum signals right through the vacuum of space, avoiding almost all of that loss. China's Mishia satellite has already proven this works, distributing entanglement over 1,200 kilometers. The future might just be a chain of satellites acting as optical relays, creating a truly global, unhackable quantum network.
So, the quantum era is no longer a question of if, it's a question of when. The technology is advancing exponentially. The timelines are getting shorter, and the stakes just could not be higher. We are in a race to unlock its incredible promise. The only question is, can we build the safeguards against its peril in time?